Hello and welcome to ZIM Explore. I am Dr. Abstract. And in this ZIM Explore, we're going to take a look at how to integrate ML5 into ZIM. Let's go to the ZIM site now at zimjs.com. Okay, we've got a What's New area, but this banner may change, so let's pop right into here, ZIM. And we can see what's new in ZIM 018. And down below here, we have the ML5 section. Another way you might be able to find that in the future, if you want, is under Examples, under Collections. There's the ML5 right here. And that actually takes us right into the ML5 example, which is fine. So it's a mini site. Right here, so that's fine. First one is an image classifier where we showed it this picture, and ML5, which stands for machine learning, said that this is a projectile. It's a missile. Okay. We were treating it as a submarine, but that's close enough, I guess. Got along the same lines. Here's hand tracking. So we say yes, and there's me, and here's my hand. Right there. We are uploading a whole bunch of bubbling videos. I hope that's not affecting our performance there. But isn't that nice? And there's my other hand. Wow. Great. Oh, my curtain's a little bit askew. But yeah, those are hands. Amazing. And here's finger tracking. So there's a little right there. See, that was not as much. Anyway, a little one. Here's a finger. Here's another finger. And so the finger tracking was so good that we thought, we could actually use this for interface now. And that's showing one finger, but you can easily get any of the fingers. And so what we're doing for interface is we're getting this finger and the thumb, and we are finding out if they pinch. And if they pinch, we're calling that a click, or a mouse down. And then when we unpinch, that's a mouse up. So that's finger tracking. Here's a hand skeleton, so similar to the hand, except we've joined the fingers together with ZIM. So you may have seen this kind of thing in P5.js or wherever, where we now have hands. Hello, I'm Dr. Abstract. And then here's pinch tracking, where we realized, oh yes, we can use that for interface. So we made two things there, and when we pinch two things together, we get a rectangle, and we can draw our rectangle and leave it. We can pinch on the rectangle to drag it. Not too bad. It's a little jittery there. We've since, like when we did the pinching, if it loses pinch as we're dragging, we put a little delay in it. So we added some features to prevent that from happening. And there's where we, I guess I got two things here, so I'm drawing the rectangle. There's us closing it. So again, two to draw. Boop, close. Excellent. So we built in some extra functionality there to make that smooth, more consistent. Because sometimes it's a little jittery. What happens? This little dot right here might go to that finger all of a sudden. It's not bad, but when you're dragging, that's when you notice. See, it just disappeared for a second, and if it ever disappears, it would stop the drag. So we put a timeout, or like a timeout, on that disappearing, and said if it comes back, then it's still the same drag, that sort of thing. But that's not in this example. So all these examples were sort of before we started working on bringing in the hand tracking into ZIM and the ZIM cam. We did a bubbling on that not too long ago. So there's a bubbling video about the hand track. I could show you where that is. It's back here. Under features, it's this one right here, the pinch. Or if you go to what's new, it's this one right here, hand track. So that's are one where we've added to it. These ones are all sort of before we did anything. Okay, so back in here, face tracking. There's my face. Okay, so we can do this in ZIM without a problem, and I suppose if you really wanted to, you could probably draw little shapes and colors and so forth on here. But there are other examples out there in the world where they actually do UV mapping, which is how 3D works to put textures onto curves and stuff. We don't have that built into ZIM. 3JS does. So you could quite easily map with a texture of a real face or your face or whatever, an animal or what have you, onto here. P5JS has that too, so that's integrated into P5JS. But ZIM does not. We don't have like native 3D in ZIM, so we are piggybacking on 3JS. If you wanted to, you could have PJS, P5, or no, not P5JS. Although that would probably work too. I mean, you could put P5JS into a canvas. Oh, that's right. We were going to look into doing that. Forgot. We did look into that. We were even thinking maybe making it for the release so that maybe ZIM 019. We'll wait for that, and we could then load any P5JS into ZIM. But we already load a whole bunch of things into ZIM. It's fun to have my face talking as we do this. For instance, video is loaded into ZIM. The texture active 3JS stuff is loaded into ZIM. This is actually loaded into ZIM as well. This is a video that is loaded into a ZIM bitmap. And then we pass the ZIM bitmaps canvas back out to ML5. All right, here's a box around the face. There to show you. So if you just want to put a round face on the face and you don't need all those points and stuff, this is probably the faster way of doing it. Just imagine you stick a circle in there, and I'd have a circle on my head all the time. And knowing where the eyes are. So this is a little step towards actually making an app with this stuff. So it can know where my eyes are, and I'm just adding a ZIM emitter to those eyes. So there's all sorts of things that you could do with this. This was a nice, simple, quick example. We'll go in and take a look at the code in just a sec. And then body tracking. Body tracking is a little bit difficult for me because I can't go back anymore. My wall's there, so I can't get a full body in there. But this is showing, we've got two different body poses. This one just puts little dots at the wrists. You can get another one that adds a couple for the hand, maybe a couple more for the head. But that gives you the main points for nose, eyes, ears, shoulders, more stuff down there. All right, for the body tracking. Okay, let's go in and take a look at some of these. Why don't we start with the image classifier there. So we've got all the code for those up, and in this ZIM Explore, we're going to go through that code. We're using ZIM 018. It actually worked in ZIM 017 as well, and probably even earlier ZIMs. As a matter of fact, it's sort of a shame that we didn't look more into this years ago when it first started. We would see our competitors doing this stuff, and we tried to make it ourselves. When we made it ourselves, we had a little bit of a slow cursor following. We had to put damping on that cursor, and that was in the ZIM cam, and it was launched a few ZIMs, maybe 5 ZIMs back ago, something like that. If we had just used the ML5 library or found out what it was doing, we built all those examples that you just saw here, all those examples in an afternoon. And I was like, why didn't we do this before? And anybody could have done it before, and nobody did. It's like, come on, you guys. We told people about it. We said, try TensorFlow. If you want to do this stuff more professionally, try TensorFlow. We didn't try it ourselves. ML5 makes TensorFlow easier. It's built on TensorFlow, and it's quite nice. So let's go in and see what we're doing here. There we are, bringing in the script for it. I expect there's probably some sort of ES6 module. I couldn't locate it easily. Maybe it was having to do it through Node.js, and I don't want to bother us doing it through Node.js. So if you're loading ZIM with Node, you might be able to load ML5 through Node as well. But otherwise, I didn't find an easy ES6 module to try and incorporate in here as we do with, say, 3JS. Like we just have ZIM underscore. Oh, am I not bringing in the cam here? I think I got to bring in the cam. Yeah. Oh, no, this is the first one, the image classifier. Let's make sure the other ones have the cam. Yeah. So the other ones have the cam here. But for the classifier, we don't need the cam. Anyway, we bring in ZIM physics, and then we are automatically importing box2D as well. When we bring in 3JS, we're importing 3JS. So we could have done the same with ML5 if we found an ES6 module. But anyway, for now, put the script in the top. Works just fine. There's a template that we're importing as well, but that's just the bar. So that's the interface right here. You don't need to worry about that usually. So we're bringing in a picture. We're starting, so here's where the ML5 starts, right here. The classifier is an ML5 image classifier. MobileNet, model loaded. This is the callback. So once this is loaded, it will call this. And so here's the function. We can then say, hey, classifier that we just made, please classify. Oh, it expects, this is a ZIM bitmap, the pic. So the image is the HTML5 image tag that's loaded from. So whenever we load a pic, we load an HTML through an HTML image, and we read that in to our bitmap. So pic.image is what you would classify. And then we ask for a result. So this is a callback to get the result. Here's our function result. And there is our results. Our results have a certain format. You can console.log the certain format to see what's going on there. So if we zog, maybe we should put this in here, zog results. Or you can look it up on the ML5 site. Do we put a link to ML5 anywhere in here? We probably should have. I expect that we do on some of the other ones. Let's have a look. Can ask ML5. This is what the results look like. There's the Handpose stuff. So yeah, there's an ML5.org. Maybe we should put a link to that as well. Why don't we go out and take a look at this, as after all it is a ZIM Explore, to find out what that looks like. So here's ML5, and there's the image classifier right there. There's also a sound classifier that we didn't put in as an example, but that's kind of neat. Didn't realize that. So there, and any of these things, most likely any of these things will work just fine in ZIM. It's JavaScript. A lot of the poses use P5.js as examples, but as you see, we just got all those to work in ZIM, no problem at all. So here is the image classifier information. There's a P5 demo. And I'm wondering if it has an example of the data that comes in. Anyway, you can read about it there. Why don't we copy that whole URL there and bring it into up at the top of the image right here. How about here? But an easy way to find out what the result is as well is just to log it. So why don't we do that and test her out here. Is this it? Yeah. So we refresh here. There it comes in and answers, F12. Oh, this is the live version, so we want a local version. Default browser. There it is locally. And F12. There's the array. So it gave red wine. Interesting. Okay, so it gave 3 answers. A projectile with a certain percentage. So confidence, It's not very confident. Is that at a 0.1? Wasn't very confident there, but I like the answer. So presumably the confidence is 1 would be fully confident, but this is only 8% confident that it's a projectile or missile. And then this one it's even less, and that one it's even less. So what we've done is we've taken the first answer and asked for its label property, and you could get its confidence as well if you wanted to. So there we are getting the results first value and asked for its label, and we made a new label. We centered it and animated its alpha in from 0, which means we don't need a stage.update. Okay, so there you go. And it's kind of nice to animate. So we have no answer, and there the answer animates in. All right, that's that one. Ooh, good, huh? All this stuff is the header, so you don't need to know about that or use that. Let's go to the next one then. Uploaded that along with its little comment thing here. And then this one is the hands, so using the camera. Let's have a look at that again. So that's our ask. For some reason our ask is, I'm saying allow while we're using the site, and it keeps asking me each time, and I'm not sure why that is. But there we are tracking both hands, or possibly even more hands, or you can make it only track one hand. And that's pretty good, like it stops tracking until it sees a bit more. But in general, it's nice, huh? Way faster than ours. Don't know how they did it. This AI stuff, I tell you. But anyway, let's have a look and see what we did here. So here's the cam ask. It's used primarily for a Mac. You might be okay getting away with it on a PC without any of this cam ask stuff. But anyway, a new cam ask, and we show it. And this is the callback. So this is our callback function right in here. Basically, we throw everything into there. Might have been there. I'm not sure why we lost our indenting. It's that one. Oh yeah, we lost our indenting. It's right there. Okay, so we just outdented this stuff. Maybe indent it one more time. Here for us, beep, beep, boop, beep, boop. I did make some claim at some point that we never launch anything without proper indenting. Sometimes on occasion, for instance, all of this script is outdented right to the edge when really it should be indented in this tag, but you know. All right, so all of this stuff is in response to the cam ask. If they've answered yes, that they want the cam, so if yes, we do all this stuff. Else, we're going to show a pane saying cam not accepted. So if we are doing the cam, we're making a new cam right there. And when the cam is ready, we're going to do this function. If the cam is not ready, then there's if an error. So if cam has an error, and we say, oh, it's not accepted. Otherwise, we're assuming that the cam's going to be ready. We don't need to do this anymore. Okay, so we automatically, we were building this in ZIM 017, but in ZIM 018, we had realized that sometimes the cam would come out wrong. Like, we thought that if we gave it a width and a height, then the config would match, but the config doesn't match. And so it was messing up certain ones. So now what we've done is we made it, when you pass this in, it collects that, it uses those dimensions and passes in a config with those dimensions too. But now in 018, we don't need that config. So it's all fixed up. That's probably going to be in each of these. Let's just try her out, make sure that that's working. Refresh. Yes. Yes. And that cam looks good. Okay. It's not needed anymore. We're going to scale the cam to the stage. Just be careful. If you're on mobile, then don't use those. Maybe, I don't know, could use width and height there. But our width and height is different here. But if your cam is going to be the width and height of mobile, then you got to handle that. You put the width and height. Otherwise, it's going to stretch this and put it into the window in an odd way, I guess. Like that's not the cam on a mobile device. So this will look not quite right on mobile, but we don't care. We're not really doing it for mobile in this mini site, so whatever. We're dropping the alpha on that. The cam's got some things, like, I don't know if you noticed this, but there's this little alpha scaler down here that you're welcome to use. That's built in. Did we pass that into the cam? Is that default or somewhere we added it? Yeah, there it is, a new cam alpha, and put it at the top left or bottom left. But that's all cam stuff, nothing really to do with the ML5 that we've got going on. So now we're preparing. We have to make a bunch of dots, and we're just going to put the dots in a shape. You don't have to do that. You could have made circles. And as a matter of fact, I think in another example, one of the other examples, we just make ZIM circles and put the ZIM circles at the data. But here we're creating a shape that is as big as the cam, but the cam might be scaled. It is. And we're going to be putting our shape is on the stage. So we're, the data is based on a non-scaled cam. So the data that we're getting back from ML5 is imagining that the cam is fully scaled. So we're taking that data and putting it into a shape. We want the shape to receive the same scaling as the cam so that it all goes on top of one another. So a bit of a schmozzle with scales there, but so be it. There we go. And then we've got a holder. What will the holder do? I don't know why we have a holder for the dots. Oh, we are doing, why do we even have a shape? This one's using dots. Did we use a shape anywhere? For some of them, I think for this one, the skeleton, we definitely use a shape. All right. I don't even think the hands one uses a shape, so let's have a search here. Any other shapes? Yeah, just two of them around, so never mind about the shape and the scaling. We'll see that later. It's not totally not a loss. So our holder is same deal with the scaling. We make a dots array, and then we're creating a bunch of dots, 42. Why 42? Why not based on just what the results have? I guess there's, looking over here, scratching. Why 42? My little hand is pointing up on there. We probably have that many, although it would have been better, most likely, to go through the results the first time or once. And this is what we did. Like, this was just, hey, could we get this stuff working? And like I said, we built it all in an afternoon, got it working. Since then, when we're doing this in ZIM, we're probably thinking about this a little bit more, catching the results once. As soon as the results come in the first time, we can find out how many dots there are. We can then make that many dots rather than hard coding 42. There is this, though. This will come in handy for you, this link right here. I hope it's right. And we've posted a request or a GitHub issue on this because these things are wrong. Is still wrong. Come on, guys. If this were ZIM, like that was a month ago. If this was ZIM, we would have fixed that within an hour. These guys are wrong right there. That is pinky. You see how it's index finger, middle finger. This is pinky finger, these guys. So anyway, we were using numbers based on that. And you see how they go 0 to 20? That's 21, so therefore we've got two hands. That's 42, so that's where we got the 42 from. So you can access any of the data by an index or by the name. It's probably, if you've got this graph here, probably easier just to use the index. We'll leave that up there in case we want to reference it. And anyway, those are the dots. We've got them waiting in this holder. We're doing creating a hand pose. So for each of those things, we saw on the ML5 site. I'll go there again and put in a proper reference here. I'm just looking around for it. Here it is. So there's the ML5 site. And there's the hand pose right there. So for hand pose, I can copy that URL and put it right on the top of the hand pose. So it's here. Once we're loaded, it calls this function. Oh, and just remember to import your ML5 up here in the script. We detect that we've got some data. Oh, this is passing in where that data will be. So where is the data for the hand pose? It's in the cam's get canvas. So the cam, ZIM cam, is a bitmap. We don't really have a canvas for it. We scratched our head a little bit and said, how do we handle that? So we don't always want the cam to make a canvas, and therefore you ask for a canvas property, because we don't need a canvas if we're just using the cam, or if we're using the cam for ZIM stuff. We need the canvas for ML5, but we might not be using ML5. So what we did is we made a method, a get canvas method, which if a canvas hasn't been made, then it will make a canvas for you and pass a reference to that canvas. So that passes a reference from the cam. Not only that, but it will update that that cache canvas. It basically caches our bitmap and then constantly updates that. So there you go. That's how we get an updating camera being fed into ML5 from ZIM. We get a result back once it started, and here's our result. And I guess the result constantly happens. And we process the result. So this is what the result looks like in this case. That we get a confidence, we get a handedness if it's the left or the right. And remember, it's going to be an array of these, so there could be multiple hands. And then it will give us the index finger of that. It will also give us key points. Is this for the whole thing? X, Y, name, and that's a wrist. So it's another technique for finding it. So this is one, that's another. And what are we asking for then? Results at 0. So the first hand. So what are we doing? For the dots, optional. We don't have to have dots, holder, remove all children. So every result we get, we remove them all. If not toggled. Okay, we have a toggle as well somewhere. Let's go have a look. So you see this little thing? Beep, toggle. Now, it doesn't get them. Toggle it on, and it's on. Sometimes it's sort of claustrophobic to always have this stuff on you. Okay, now I can move my hand without these dots on them. And toggle on. So if it is toggled, or if it's not toggled, then we're going to get out of here and not bother. We just remove them and they're gone. If it is toggled, we keep on going. If there's no results, if there is no zero results, that means there are no results, then we return. Otherwise, we're going to loop through the results, and we're going to loop through the results key points. Okay, so we did loop through the results key points, because that's going to give us basically an array of X and Y positions, and that's all we're going to need is the X and Y. So then we're going to the dots that matches the count. Here's the count of 0. The dots at 0. So the first one, we're going to look at the X and Y in the holder and then increase our count each time. Actually, we could just increase our count there. As long as that doesn't fool you. That's a post assignment operator. So if you put it in here, the first one will be 0. Then it will increase it, and the next time it comes around, it'll be 1, and so forth. So that also works. Let's have a check there and make sure. There we go. Let's see when we refresh here. Yes. So this has nothing to do with ZIM. Allow this time, never allow while visiting the site. That's what I thought that was. Okay. So allow while visiting a site. If I refresh, it asks again. So I don't know why it's doing that. We'll do a little search and figure it out. Oh, I'm pretty loungy here. I'm viewing invisible. All right, so let's move that over there. Do you get what we've done? The rest of them are very similar to this, where I won't have to explain quite as much. And so the general idea is we're looping through the data and putting these dots that we made at the data. All right. Templates. So we made sure the template comes up on top of the camera. We put the little alpha thing there. We added the toggle. And those are some error messages. All right, I think that's it there. So next one, a finger. If we wanted to get one finger, you can imagine it's a little bit easier because we don't need all the dots. We've made 2 circles this time, a left circle and a right circle. We get the hand pose loaded again. We find out when it begins. We pass in the canvas from our cam. We have the same kind of data here, and we are removing both the circles to start by default. If it's toggled off, then they're gone, and we're good. If we don't have any results, they're gone. That's good. Otherwise, these things hang around, so that's why we remove them. And then we're looping through the results, and if the results handedness is left, see how we get the handedness on this? So when we loop through the results, this is one thing. Another hand would be a different thing. It would be another object. So if we've got a handedness that is left, we are going to circle left, look at the index finger's tip. So the tip of the index finger, remember this guy? Index finger tip is number 8, right there. So that's where we're going to put it. Index finger tip times the scale of the cam plus the X of the cam, and that will locate the circle. Do we even make a holder? No, we didn't make a holder. So we've just got the circle right out loose on the stage, and therefore we're scaling that data as we go on the fly. And that's the Y's position. If it's the right-hand side, then we add the right-hand circle and locate at the X and the Y scaled, like that. So it's a finger. Skeleton. The skeleton we've drawn lines between, so all of that stuff is pretty well the same. This time we are using the shape, but did we need the holder then? Yeah, okay, we're going to use the dots from the holder. I think what happened is the way we built all this out is we made the dots, we added the skeleton, and then we realized, oh, maybe we can just show a simple example of just the dots. We reverted, took away the skeleton, and forgot to take away the shape container there. But this uses both so that we have the dots and the skeletons. And then our shape, what we're doing is when we've got some results, we're clearing the shape each time. So shape.clear, set the stroke to a light color, set the stroke style to 2. And so that's important because each result we'd want to start it over again. We're also removing all the children, and then we're returning if there is no results. And otherwise, as we loop through, we're looping through and putting the dots in the places. So that's the same as before. It's optional. As a matter of fact, if we don't put the dots there, then it would look like this. I don't know if this goes to locally hand skeleton. Yeah, it's local. Okay, also looks cool. So that's no dots. It's just the lines of the skeleton. I mean, it's so magical. It's just amazing. Amazing. All right, so that's without the dots. And we're drawing our shape. So we looked at we tried to figure it out. How are we going to draw a line? So we started from the palm, drew a line to 1, 2, 3, 4. So we started with the palm. Line. All right, we made a little function for ourselves. Did we? Yeah, there it is, line. So we have an array of points, and we're going to loop through those points and draw a line to the points X and Y. So that allows us to make this look a little bit easier. So draw a line in the shape. What is P? P is the key points. So that gives us all the data for those. And there's which numbers we want. 1, 2, 5, 9, 13, 17, 0. Why? 1, 2, 5. Look, so we're starting at 0? No, we're not. 1, 2, 5, 9, 13, 17, 0. So this is our first shape that we drew, which is the palm. Then we drew 3 to 4. Oh, why just 3 to 4? Right here. So we had something else here. Move to. So we did a move to number 2. Oops. We did a move. So we just drew all this stuff. We did a move to number 2 there. I should put this so that you can see it. So we moved to number 2. Then we drew a line to 3 to 4. So we're here to 3 to 4. Then we're going to move to number 5. So we move. Move means pick it up. Pick up your pen and move it. So we moved to number 5. Then we drew to 6, 7, 8. Then we moved to number 9 and drew from 10 to 12. We moved to number 13, drew to 16, and finally moved to 17 there and drew 18, 19, 20. 18, 19, 20. Okay, so that was us. Each time we get some data back, we draw that. Next, pinching. So pinching will be a little bit different. Why don't we leave pinching? Well, okay, now we'll do pinching now. A face will be the same as the fingers. Box will be pretty well the same. Eyes, close, but we add some ZIM stuff to it. Body will be the same as the fingers. So we'll end up going quickly through a few of those. This one, the pinching, is a little bit different. So it's along the same lines, though. We are creating circles for, so we have a dots container. Do we need a dots container anymore? I don't think so. Dots. Dots, dot, remove all children, dots, dots, dots. So there are some dots. Okay, yeah, we're putting all these in dots eventually. So we're making the fingers here, but note we didn't add them to the stage. We'll eventually put them into the dots container. So we have our fingers, circles made. And what we decided to do for the pinching, let's go there now, take a look, is make the thumb be sort of a pinch tracking circle. So, well, they're both circles, but sorry, a ring, a ring, I guess. So it gets a ring as a secondary, where this is sort of the main dot we're concentrating on. And what we do is when we hit test the two of them, bing, we put a dot at where, I don't know where we put the dot at. It's kind of odd because the dot moves in. It's like the dot goes on the edge of the one circle, which is fine. I think that's just between, center. So it's at a position between the two centers. So we've got the center of this one, center of this one. We put the dot at the center. I think I left it there. That seems to make the most sense. Oops, we got, see, another one came in and they thought there was a left hand here even though there wasn't. But that's pretty cool, huh? For the most part, it's pretty darn good. Okay, we let go and I can pick that up and drag it like so. And then we close down like that. For our pinch in ZIM, we also made it so that you could turn off the pinch and on the pinch by pinching the end two fingers together. So just like we have a pinch there. Oh, it didn't make it so you don't have a pinch on there. I mean, maybe it would have been a good idea to do that, but you can actually pinch anywhere and move it. It's having a problem. It's thinking there's a second one there. Sometimes you run into a problem if I'm over my face, like it makes it a little bit harder to find. It's still pretty darn good, but I have noticed that sometimes if it's in the face, you lose it a little bit. Still, yeah, pretty good. That was a pinch, an accidental pinch. That's interesting. I moved my hand like that when I put it down, and I'm not pinching really, but they're overlapping still. Anyway, I found as well that it helps to be back a little bit. It then really picks up the hand well if you're back a bit. It's a bit harder for it to pick up the hands it's doing well when you're closer. All right. So the thumb is clear. These are the thumbs with the clear, and they're a little bit bigger. And then this is the little white pinch thing there. We run the Handpose again. We pass it the ZIM camera canvas. We're getting a result each time. That's what the results look like. We're using those same results, except we're tracking specifically the index finger tip and the thumb finger's tip. And so basically we're locating, we remove all the children from the container, and then we locate the ones that we have. So if we have a left hand, we locate those. If we have a right hand, we locate these. And then we're doing a hit test each time. If the left finger is hitting the left thumb, then we're adding the left pinch as well at half the distance between those two into the dots. And if the right finger is hitting, then we add the right pinch. The next time we get some results, they might not be hitting anymore. And because we've removed them all, if they're not hitting anymore, they don't get added. We have a remove button here, and then what are we doing? Let's see. When we tap on it, remove. That's an X. So if we physically tap on it ourselves, so this is us saying, look, I can remove it that way too with the cursor. But we also want to remove it with our pinch. So here's what that is doing. Oh, this is a combination. We have to draw the rectangle too. So constantly be checking if toggled return, or if not toggled return. So that means if we're not wanting, if it's this thing down below here, this toggle, if that's off, we don't draw anything. If it's on, we do draw things. If it's off, oh, okay, well, it's there. We got to erase it. This is really only operating on the hands. So if the left pinch parent and the right pinch parent, if both of them are there, so otherwise, if there's a left pinch parent, we are going to, and if not, remove parent, return. Don't know what that's about. We'll have to come back to that. But if they're both there, we're going to draw a shape from the X to the width and height sort of thing. So we're drawing into that shape. That's a draw rectangle. That stands for draw rectangle from the X to the width and the height there. And it looks like we've got, I don't know why we have a start left and a start right null. Maybe some of that, I haven't looked at this in a while, some of that will become apparent at some point. I don't know where we're using it. Optional move. Oh, this is if we're going to move it. Okay, so that relates to moving it which we may or may not want to do. But anyway, that's us drawing the rectangle. Oh no, this is us drawing the rectangle. We still can move it. Okay, so even if we don't have, this is us, if we have 2 pinches, we draw the rectangle. If we have just 1 pinch, we might be moving the rectangle. So this is us moving the rectangle based on, and that rectangle isn't really moving, we're just redrawing the shape. So that's optional, and possibly we could have drawn the rectangle, and then as we pinched, we could have actually moved the rectangle, but we have decided to redraw the rectangle based on the amount of movement. In the end, this has all now been integrated into ZIM so that we don't have to do that, although I think if we wanted to draw a rectangle like that, we would still have to physically, or not physically, but do something like what we just did in this example. But dragging it, we wouldn't have to do anymore. Dragging it would be all we'd have to do is say rectangle.drag. And when we pinch on the rectangle and drag it, it would drag. We don't have to do anything with this X. If that X already has a tap on it, it would be done. Oh, that was fun. I don't know if you noticed that, but I pointed at this. It's almost like it was neat. If you shoot a gun, it's neat. Well, not quite. Anyway, it's kind of like you get a pinch if you point, but you got a oh, neat. Yeah, that's neat. So a pinch move is also the same as a point and put your thumb down. I love it. All I'm doing is that, and if you're facing it, it's got a pinch. So it actually does a shoot as well. Fantastic. Call it shoot tracking. The integrated, yeah, so make sure to check out the integrated, because the integrated would have made, we wouldn't have had to do this with the integrated. We wouldn't have had to do how we found out the remove right here. So this is us doing a hit test bounds. Is the right pinch on the remove button? Is it hitting the bounds of the remove button? Then remove it. And we have one for the left as well. If the left pinch is live, so left pinch has a parent. That's another thing. We now have properties for that. We don't have to ask if it has a parent. When we integrated it into the cam, we gave it properties that kind of make sense. Although asking for a parent is pretty easy too. But this was when we realized, oh, hey, this works pretty neat. We could maybe integrate this into ZIM. This is how that came to be. And then we went from here and added some conveniences to it. It's almost we want to go in there and just take a quick scan and see what those conveniences look like. Why don't we do that? It is, after all, a ZIM Explorer. How long are we in this Explorer? Remember, you're welcome to go out and grab a cookie here. Welcome to explore the cupboards and get a little snack and then come on back. You don't have to listen to all this at once. We have to talk all this at once. We're at 48 minutes. We have to talk all this at once. But you don't have to listen to it all at once. So yeah, we won't take it. I'll just show you how much was in there. We won't go through every line on it, but we'll just tell you where it is and show you all that stuff. That's the integratedness. So I think we're done with this one. You get the idea, right? There might be some things in here that we didn't look specifically at, but it looks like we got most of it. And while we're at it then, why don't we go grab the docs and take a look at, oh, that was in the cam that we integrated that in. Ooh, the word integrate. Ooh, why don't I just use added? So in the CDN here, I'm looking for the cam right there, cam 1.3. And here it all is here. It's not all that much. Come on, surely. Yeah, so there it is. I must have been right at the bottom of it. So there it is. Here's the ML5 support. It has 2 classes, primarily a prepare track, which builds all the fingers and stuff along the lines of what we were doing and makes a finger. There's an active, if the finger is active. We also damp the fingers, so that makes them move more smoothly. But we don't have to damp as much as we did with when we did the ZIM cam with its motion cursor. We had to damp a lot. Here we're just damping a little. We're also adding whether we've removed it or not, because we are setting a timeout before we remove. So if we want to remove it, we don't remove it. We wait a timeout, and if the timeout goes and we still want to remove it, then we remove it. So that allows a smoother dragging. So we built that into here. We have different cursor modes too. So you can use the pinch just like we did in that example that we were looking at, without it actually taking over the ZIM cursor, because that's what this integrated means. It means that when there are fingers showing, when we see finger cursors and pinch cursors, that means you cannot use the mouse or touch. It takes it over. But that's optional. So we had to build in that, whether it's automatic, whether it's always true, or whether it's never true. So 3 settings on that. Blobbity blobbity blah. Don't know what all that's doing. We initially made it so that we could turn it on and off. If we pinched both of them and touched them together, then that would activate the cursor or not the cursor. So in other words, we could say, let's bring back the ZIM cursor. In the end, that needed two hands, so that doesn't really work, because we decided that it's actually good functionality to just do this with one hand. It's a bit more stable with just one hand. So by default, we're doing the pinch only with one hand. Usually you just have one cursor, like one mouse, and you can handle lots of things. So just use one hand. You can use 2 hands, though, if you want to do multi-touch kind of stuff. But this way of turning it off and on only really works with 2 hands, so we took that away. And instead, we have pinching the pinky with the thumb. We'll turn it on and off. And that way, both hands can turn it on and off. There we are doing some testing of the hit tests. Oh, here's us working out the time and stuff. There's us calling the remote cursor. So this is moving that pinch stuff and taking over the cursor. So if we don't have a hand, we're going to remove that remote cursor. You probably see something down. This is adding it, but somewhere in here, we're going to be removing it if that happens. Add, remove. Okay, so that's whether we want to replace or not, but you'll find that in the code as well. So these are some properties, working through the cursor mode changes, changing the scale of these things. So you might want to scale those little circles that we have. That's in there. Then there's the hand track method. So this one was in the preparation for it all, and this one is what does it do as we're getting the data. So you pass in the data to this one. It makes all that a bit easier. You can go take a look at how we did that. And then do you recognize it? It's accessing all of the data with the scaling. So all that stuff has been abstracted. You don't have to think about it. It's all in here. And we're checking a finger. So we made sure that we can handle left hand, we can handle right hand, we can handle both hands. And in each case, we just call a function to do that. So we don't have a function for left hand anymore and a function for right hand like we did in those examples that we saw there. We've made it work with just one function, and then we pass the hand in. We can also get the distance and get the angle behind there, and there you go. That's what's built in now into ZIM 018. Well, actually, it's into the CAM 1.3. Woohoo! All right, let's close that down, though, and quickly look at the final 3 or 4 that we had here, the face. So this is the little dots around the face, and it's basically going to be doing the same thing, I'm sure. Well, I think this had so many dots that we decided to put them all in a shape. So we made a shape, and then we looped through and drew a circle. That's draw a circle right there. So we moved to draw a circle. You move to the point, the center point of the circle, and then you draw the circle. Actually, you don't have to. Yeah, you have to move. Otherwise, even if you draw the circle at that, you would get a line going from the last circle to the center of this circle. So you have to pick up the pen, in a sense, move it to where the circle is going to be, and then still draw the circle at that location. This is, by the way, this is native Create.js side. Yeah, native Create.js. And that's how you would draw a circle in Create.js. We looked at this and said, let's just make a circle class. So that's why we have new ZIM circle. And we don't have to put an X and Y. The X and Y is handled with center, loc, pose, whatever. Add to. So X and Y, all that. So it's independent of the circle. Just like the buttons are independent. The X and Y are independent of the button, etc. So we made our ZIM shapes like that as well. But CreateJS did not do that. So anytime we wanted to draw a circle, we'd have to actually go back to make a shape like that. So ZIM's done a lot to help out CreateJS. It's now something like 6 times bigger than CreateJS, 5 times bigger than CreateJS, and so much more convenient. So there you go. All right, where are we at? That's it. Okay, so we just drew a bunch of circles wherever the face circles were, and I think you can imagine that that's very similar to the other stuff that we were doing, where in comes the face. The waiting face. There it is. And we drew circles at the little points. By the way, you also have some information on those circles. Did we provide it here? No, we didn't. So you can get... here. Okay, yeah, so that's what it looks like. We do know where the lips are, where the eyes are, where different things are. And each time you get this kind of stuff. All right, same as what's up above. And you get key points as well. So in the next one, we're going to show you, well, actually, I guess it's not the box. I think that's a different pose. So this is called the face pose, isn't it? Face pose. All right, but it works basically the same way as the hand pose. What is the box? The box is a face pose as well, and then right, the data. Look, it gives you a box. Okay, so the box is using the same data, except we're just using the box data to draw a box. So there's drawing a rectangle. We move to the box X and Y min. We draw from the X min, Y min to the box width and box height. Okay, and then we close the path. Close the path, by the way, as you move around, or as you draw lines and you make an angle, that little corner gets beveled automatically, but the last one, when you stop, doesn't bevel to the first one unless you close the path, a CP on the end there. And so then your box is full. Let's go see that nice box that we drew. We may not be able to tell if the line is thin. Usually you can't tell. And we have an error on it. Well, that's good. I'm glad we checked on that. What is the error? F12. Container is not defined. The template 1. I have no idea what that is about, but we'll check that out. That must be a local issue. I found it. Just forgot to uncomment the import on the cam there. All right, that makes more sense. And there we go. And we'll allow this, close that. And there's our box. So we got the data, same data as all those little dots, and we just are choosing the one that is the box. And it's a very nice box. Okay. Woohoo! Next one, the eyes. We're also using the data here. So this time we're using, well, same as before. We use the same pose, which is the face pose. Where'd it go? It's in here somewhere. Looks like we're preparing an emitter, and then there's the face pose, face mesh. And this time we're using the left eye and the right eye. So we made 2 emitters. There's the left emitter and the right emitter. We just cloned the left emitter. We've just centered both of them for now, but they're starting pause, so we can't see them. Then we are getting the left and the right. That is the results at 0, so the first face that we detect. We could actually detect more faces if we made more emitters, so we could make emitters based on how many faces we have. So if you have a crowd and want to have everybody's eyes go, you can. Probably. You know. So just at that point, then you need to find out how many you have to prepare for a bunch of emitters. and only use certain ones depending on whether they're there or not. So we're then locating the emitter at the data for the left eye. So that's the result zero's left eye data, which has a center X and a center Y. So we're probably using those. Yep, we're locating the emitter at the left center X, putting in the cam scale and the cam's X. Same with that. And we're just spurting once. So this is, and it seems to do it. I mean, this was our technique for doing that. So face eyes here, yes. Seems to be pretty smooth, or smooth enough. Okay, that looks, I mean, if it's not smooth, you can tell. You can tell when I jostle a little bit that I get those rings, but if I don't move at all, it's almost, it's very, very nice and consistent. So that looks pretty well like a normal emitter. So basically, in time, as we're getting the results, once we get a result, we just say emit one particle, emit one particle, emit one particle, emit one particle. That seems all right. Fun, huh? You want to see what it looks like with one eye? My right eye. Is that my right eye or my left eye? Let's see. That is, that's my left eye, isn't it? Yeah, I think so. But we flipped the camera, so that's it appears to be the right eye here, but that would be my left eye. And let's see how they treat that. Yeah, left eye. Okay, so just remember that. Let's flip for you. It surprised me for a sec. Okay, that's that one. Yay. And then the body pose. Body pose just like the other ones. So the body pose, we bring in, what are these options? Oh, right. There's a couple different types. So it's almost just like the other ones. This is a config or an options property that we can pass into our body pose. And we're asking for the multi-pose lightning. There's also single pose lightning or single pose thunder. And I don't know, they do different things. You need to go here to the body pose. So in this case, we did put the body pose there. Oh, that reminds me, did we put the other face pose link into the face pose? I don't think we did. So let's just quickly find that. Put it there. Thank you for helping out. All right, so that's the hand pose. We'll go back and choose the face pose, face mesh, I guess it is called, and copy that. And we are in the face, and there's the model right there, and it had options too that we didn't mention. So there are some options, and we passed in those options to our face mesh when we made it. Okay, so that's good. That would be also in the eyes. May as well, just in case they only see the eyes, put that in here as well. Oh, that was disappointing. Okay, and was that it? The box. It's in the box. The box. Options. All right, all those have been updated. And this is the body. So we could find out the information about it. I think there's some diagrams in there too. Let's pop on out and have a look. So this is the body pose. Is there a nice picture? Come on, picture of the body, picture of the body, picture of the body. You'd think that they, oh, there are the pictures. So this is the one that we used with just the stems on it there, and this is bodyPose's moveNet model, 17 points. That's what we did. There's also this one, which is the blazePose, bodyPose's blazePose model, and it has more stuff. So little hand bits, little eye bits. I didn't bother, little feet bits. Okay, and that would be, you would pass in, I don't see where to do it, but it probably tells you. docs undefined, model URL undefined. Anyway, somewhere in here you would be able to set the blazePose or the, let's do a search on blaze. Okay, options for the blazePose only. So how do we get a blazePose though? Maybe it's a different pose completely. So maybe this is the bodyPose. It's kind of got information on both of them though. moveNet. That's moveNet, blazePose. Looks like they're both in the bodyPose. Sorry about that. Well, keep on searching Blaze, I guess. Blaze. Okay, so the bodyPose, blazePose. We've got bodyPose null, the default, which must be there. So just right in here, you would put a blazePose. Why don't we put a little message there? Instead of default null, default, which is what? What's the default called again? It's their other pose. Sorry, just looking it up here. moveNet. moveNet, yeah. Instead of default, moveNet. That's the null. You can pass in quote. How did that look? Oh, I lost it. blazePose. Got the quotes there already. Do you think maybe I could just duplicate this? Pass in the blazePose. How does that look? Okay, so that's a different pose with different results. Blaze, better say if using blazePose, then results are different. See. ML5 docs. bodyPose page. Okay, where should we put those? How about at the bottom? Okay. All right. So we still get a bunch of points for all that kind of stuff. So there they are, and we're looping through all of those points and making a little circle there, drawing a circle there. That's all. So same as basically all the other ones. We're removing, or we're clearing the shape, and if there's no data, then we don't even bother drawing anything. If there is data, we loop through that data, and we draw a point at those body points. Yay! We are done, ladies and gentlemen and others. That's pretty amazing. I'm glad that you are here with us at ZIM. So, I'm still glad. Yeah, that's right. Glad that you're here with us at ZIM. And once again, all of those can be found just down below in here, or a little mini site under collections, under examples. And there is more out there as well. There's a way that you can show the face and blur out the background. We took a peek at that, and it wasn't immediately easy to put in place, but I think it can be done. And we just we're busy with the whole of launching thing here, and just said, okay, you guys do that. You're the developers. All right, we've shown you that we can integrate just like any other place. You'll need to sort of see how their examples work with P5.js, and you should be able to integrate something in ZIM, or maybe when we get more time in the future, we can have a look at that if you bug us enough. Okay, so all those updates as well are available here in the ZIM, and we talk specifically about the ML5 examples talk a little bit more in here as well about the history, and provide all the links again to those examples there. Come on in to ZIM, the ZIM forum, and we would love to see you. Let's see, where's that? That's up here. The forum or Discord, and say hi. Tell us what you're building. Ask us any questions. We would be happy to help. And this has been a What's Bubbling in ZIM. I am Dr. Abstract. Oh, it's not a bubbling. It's an Explorer. I should know from the sounds. So this has been a ZIM Explore, and we've been looking at the ML5. Thank you very much, ML5 folks, and also anybody who is providing examples in P5.js. You did a good job there, made it nice and simple for us, ML5 folks, and hopefully you've enjoyed seeing how that all works inside of ZIM. Have a great day or night. Like I said, come visit us at the forum. Cheers. Give the video a thumbs up too. Bye.